From number 9 to 23. I just
All of
don't
those, huh?
know. 10 to 23, actually. I got
Okay. Well, okay. You got number 9, which was,
Yeah,
that's a
that
good
was
start.
easy.
Okay. Well, I've got it. I can share my screen here. Let me go. So I'm working on I got my laptop set up for my camera feed, and I'm working on my iPad to kind of show y'all what I'm doing. So let me stop with the whiteboard app. All right, and I'm going to share my screen with you so you can see the assignment. And hopefully, can you still work along with me while you're watching the screen?
Sort of, yeah, I can sort of split screen it.
Okay. Another thing we could do is I could go back to that whiteboard because we can all write on that whiteboard, and I could just copy the problem over onto the whiteboard and we can talk about it together. So just let me know if the system is not working, and we can fix it. All right. So now you should be seeing the assignment. All right. So the most important thing to remember when you're doing this is you can really do these steps in any order you want. There's a couple rules that we have to follow. We always have to follow the order of operations, but I usually like getting rid of negative exponents at the end of the problem, but you can get rid of them at the beginning of the problem too. So number 9, hopefully we know that this answer is 1, right? Anything to the 0 power is 1. But for number 10, so are you having trouble with understanding what the rules do, or just how to apply them in these problems?
Both.
Both? Okay.
Yeah.
Okay, so remember, I've got the notes. I brought in my version of the notes, so we have the rules here. We can look back at them. So all 7 rules are right here on this page. All right, so in number 10, what's the only thing that needs to be simplified?
The -8. Right,
because right here in the directions it says you have to write your answer using only positive exponents. Okay, so so we look at the negative exponent rule, and it says if you have look, it has even got a laser pointer here. Isn't that cool? You have a negative exponent. To make it a positive exponent, you move it to the other side of the fraction, right? So if it's in the top of the fraction to start with, you move it the whole thing to the bottom. If it's in the bottom to begin with and it has a negative exponent, then you move it to the top, right?
Yeah.
Okay, so that's all we're going to do here. Remember, whoops, gotta switch back. Okay, so if we were to write this in fraction form, that's how we do it. That's how we do it for all numbers and all variables. If it's not a fraction, then it's in the numerator of a fraction, and we just put it over 1. So to make it positive, we just move the power to the bottom, and we change the -8 to a +8.
Oh.
So that's all we can do to simplify that problem. Since we don't know what A is, we can't raise it to the 8th power, so there's nothing else we can simplify. Make sense?
Yeah.
Okay. So now these rules, like I said, they kind of work independently of each other. You just use whatever you have to in every situation. So like in 11, we have 3 bases here. That's another common mistake. A lot of students think that this 6 is connected to the A to the 0 somehow, and so like 6A is being raised to the 0, but it's really not. If it's a base, if it's on the main line, it has its own exponent, unless it's in parentheses and like everything in the parentheses is being raised to a power. Like, let me find, like this one, 22. Okay, here we have 2 different numbers in parentheses are both being raised to the -3. The parentheses indicate that both of these bases, this one and this one, are being raised to the -3rd. But that's not the situation we've got going on in 11. So what we're going to do when we simplify this, we have a 0 exponent. All right, so we know that A to the 0 equals 1. And then we also know that B to the -2nd is going to be the same as 1 over B to the +2nd. All right, and the 6, can we do anything to simplify the 6 to the 1st power?
No.
No, so that's just going to stay where it is. All right, so So really what we have here is 6 times 1, because a to the 0 is 1, times 1 over b squared. All right, so if we put that all together, the 6 and the 1 are all in the numerator. So if we multiply those together, we get 6. And in the denominator, we only have one term, the b squared. So this is how we could completely simplify our answer. Sound good, Cheyenne? Everything looking good on your part, on your end?
Yes.
Cool. Okay, so you want to look at one that's a little more complicated?
Yeah.
All right, let's do 13. Okay, so you kind of helped me out with this one. What needs to be simplified?
The -2 and -3.
Right, the exponents that are negative, and then there's one other thing that we can simplify.
The 0.
Right. Okay, so I always start by doing this. S to the 0, that's going to be a 1. All right, so let's take that out to begin with. Remember, it's not s to the first power. It's not 1s. It's just 1. All right, so really we have nothing in the denominator. But we know that because both of these powers have negative exponents, we're going to have to move those into the denominator, right? That's how the negative exponent rule works. All right, so we actually have nothing. We're going to have, when we simplify both negative exponents, we're going to have nothing in the numerator except a 1. I mean, there can't be nothing there. We have to have something. And we're going to move 3 squared to the bottom and r to the third power to the bottom. So we're going to have 1 over 3 squared times r to the third. So we make those exponents positive, and now we can work with them. Now the r to the third power, nothing we can do about that. We don't know what r is, but 3 squared we can simplify. What is 3 squared?
9.
Right, so that gives us 1 over 9r cubed, or to the third power, however you want to say it.
Oh.
So simplify your negative exponents first. Some students like doing it first, some students like doing it last. It all depends on what you have in the problem. Okay, and you can see how I did 14 here. I moved the negative exponents. I moved them all where they belong first. So let me get my laser pointer out. Okay, so 2 to the positive third, that stays where it is because we don't need to simplify a positive exponent. A to the negative third got moved to the bottom, becomes a to the positive third. 8 to the negative 1 got moved to the top, and b to the negative 5 got moved to the top, just so we can make everything positive, right? Okay, and then of course c to the 0 is 1. So in my next line, there is no c because we're just multiplying whatever's on the bottom. We're multiplying it by 1, and multiplying it by 1 doesn't change anything. So, all right, so yeah, in 14 we have 2 to the third times 8 to the first times b to the fifth over a to the third. When the dust settles, we get rid of all those negative exponents and 0 exponents. So now the only other thing we can simplify in this one is the numeric bases. The variable bases are kind of just stuck because they're not the same. So it's not like we can use the quotient rule here and subtract the exponents because the bases aren't the same. So we do 2 to the third power, we get 8. We do 8 to the first power, we get 8. And then we can multiply 8 and 8 and get 64. But like I said, the b to the fifth that's on top and the a to the third that's on bottom, there's nothing else we can do with them. Okay, so what else? I'm gonna eat some French fries. Let's talk about 18. What rule are we going to use here?
The product rule?
Not product rule.
Oh, the power rule.
Right. Power rule because there's only one base. It's a base with an exponent being raised to another exponent. So that's what it looks like. So we're going to multiply the exponents. And this is where it can get a little tricky, but it's not really confusing as long as you know what rule you're using. So the long way to write this out would be q to the 5 times 3, like that. And then all we have to do is multiply those exponents, and we get q to the 15. Okay, so knowing when to add the exponents and when to multiply the exponents is a big difference that we need to make in our minds. If we would have had the problem q to the 5th times q to the 3rd, that's when we would add them, and we get q to the 5 plus 3, or q to the 8. So that's the big difference here. Like here, there's 2 different bases being multiplied together. Here, there's just one base being raised to a power twice.
So for 17, would we add the 3 and the 3 because it's out of the parentheses?
Exactly, yes. We have negative 5 to the 3rd times negative 5 to the 3rd. The bases are exactly the same. Even if it's negative 5 to the 3rd and positive 5 to the 3rd, you can't use the exponent rule, but you can simplify them using your calculator, and then you can multiply those numbers together. Either way you do it, you're going to get the same answer. So, oh man, I wish I could show a calculator. I didn't really think about that. But where is my calculator? Right back. Yeah. So if for 17, if we follow the rule, we're going to add the exponents. So that gives me, oops, negative 5 to the 3 plus 3, which is 6. Or if we simplify these, we go ahead and type in our calculator, negative 5 to the 3rd power. That gives me negative 125. So negative 125. This is also negative 125. Okay, and if we do both of these, now if we multiply negative 125 times negative 125, we get 15,625. And if I do negative 5 to the 6th power, we should get the same answer. And we do. So I don't know, maybe you can see that on my screen. But we get the exact same answer either way. So it's kind of, we usually don't have the freedom to do it in any order we want, but with exponents, we kind of do. We can either multiply them together first using the exponent rule and then simplify it, or we can simplify them both first and then just multiply them together like we would normal numbers.
How would we do 23?
Okay. 23 is one of the new ones that we learned this week. That is the power of a quotient rule. So if you have, and here's a good example. If you have a fraction in parentheses and the whole fraction is being raised to a power, you just distribute that power, just kind of like I did here. You distribute that power to every exponent in the parentheses. It doesn't matter if it's on top or bottom. You multiply the exponents for every base there is. So in this example, you can see I did 2 to this 2. I put that 1 in there because any base that doesn't have an exponent has an exponent of positive 1. So this is 2 to the 1st, a to the 3rd, b to the 4th. All we do is multiply every single one of those exponents by 2, and then we get our answer here. So 2 to the 1 times 2, a to the 3 times 2, and b to the 4 times 2. All right, so if we apply that down on number 23, we're going to do 4. Remember, both of these have an exponent of 1 right now. So 4 to the negative 3rd on top, and x to the negative 3rd on bottom, okay? Now what do we have to do next? Because we can't leave our answer like this. And let me ask you why. Why can't we leave our answer like this? Maybe Cheyenne knows.
Because of the negatives.
That's right. We can't have negative exponents in our answer. So how do we get rid of negative exponents?
Flip it.
Yep, we move it to the other side of the fraction. So since they both have negative exponents, we're gonna flip them, and we're gonna make those exponents positive when we do that. So x to the 3rd over 4 to the 3rd is what we actually end up with. And then we can do one more thing, and what's that?
I have no idea.
Yes, you do. Look at this expression, x to the third over 4 to the third. What can be simplified?
Oh, the 4/3.
Right. Any numeric base can always be simplified. So if you do 4 to the third power on your calculator, you should get 64. All right, 4 times 4 times 4 would give you 64. And then now we're finally done. Oh, that's not what I wanted. I didn't know it made pentagons for you if you wanted to.
Hmm.
Okay. Hopefully part 3 is a little bit easier. I know the problems on the practice part are a little bit tougher than the ones on here, but once you understand how to do these practice problems, the application should be not easy, but a little bit simpler. Okay, so do you want to try another one, maybe on your own, and
yeah.
we can see if you're doing it right? All right, what number?
12.
12. All right, so I'm going to do this. I'm going to go, all right, I'm going back to Zoom. Okay, we're gonna, nope, sorry, wrong one. I'm gonna bring the whiteboard back up. And how do I get out of full screen here? All right, so what was the problem? 14.
14m negative 4 to the power, I guess, and then n to the power of 0.
Okay. Okay, so you should be able to write on this as well. So if you just want to use a different color, go ahead and simplify it completely, and we'll see how you did.
Oh, cool.
Yeah, isn't it?
Oh. I'm stuck.
Okay, what is n to the negative 4th? How can we rewrite that with a positive exponent?
We would put it in a fraction.
Yeah, we would. It already is in a fraction. That's the way you got to think of it. It is in a fraction. It's over 1. So we're going to move it from the numerator to the denominator to make it positive. Okay, now, does the 14 go with it?
No.
Very good. Very good. The 14 has an exponent of positive 1 right now, so that's going to stay put in the numerator. And then the n term is just going to drop out altogether because that's equal to 1. Okay, so when the dust, almost, except this negative sign should not be there because that's not a very good arrow, but remember the reason we're moving it is to make the exponent positive. So you want to change that if you want to draw an equal sign here.
It won't let me erase it.
I know it's not the greatest whiteboard app of all time, but it is kind of cool that we can all write on it at the same time. Okay, so now if we have 14 on top, m to the 4th on bottom, and n to the 0 just kind of drops out, then what should our final answer be?
Wait, 14 on top?
Yeah, because remember, there is a laser pointer app too. So this 14 right here, it still needs to be in the problem when we finish it. And since it has a positive exponent, it's not going anywhere. And there's nothing else we can do to simplify 14 to the 1st power. So that just kind of it just stays where it is. It hangs out in the numerator of our answer. Yeah, so this would be your final answer right there.
Oh.
So for each base, you just gotta know, like, ask yourself, how many bases do I have? And then take each base and simplify it if you can all the way through. You know, do whatever you can do to simplify it.
Okay.
All right, so I wish I could bring up, I mean, I guess I can on my laptop since you can't see that. Do I have the 6.1 performance packet out? No, I don't. Okay, so do you want to try some other ones?
Yeah.
Okay.
So for 15,
Mhm.
it's the quotient rule, right?
Yes. All right, so let's go ahead. We'll erase all this. All right, and black. Yeah, that's just the quotient rule. So as long as you understand how to use this rule, it doesn't get much simpler. Okay, you just got to make sure you always ask yourself, do I have like bases? The bases have to be the same before you use the rule. So that's going to work in our case. Our bases are 3. All right, so show me how you apply the quotient rule here. And Cheyenne, you can do it. You want to work it out on the left side, and Haven can work on the right side. We'll see if you get the same answer. And I'll eat my French fries.
Is that it?
You win. I don't think you can see me, but yes.
I can see you.
But you're not done yet, are you?
I guess not.
What is 3 squared?
Oh, 3 squared is 9.
Okay, yes. And I'm going to show you something. I did show it in the notes with the what I call it, the how it works section of the notes, like why it works. If you get in trouble, this goes for pretty much any exponent problem that you can do. If you get into trouble, you can always do this. You can always write it out in expanded form, and sometimes that makes more sense to students. So 3 to the 5th power really means 3 times 3 times 3 times 3 times 3. 5 3s multiplied together. And then 3 to the 3rd power on bottom means 3 3s multiplied together. And what do you get when you divide a number by itself?
1.
1. So 3 divided by 3, those are 1s. 3 divided by 3, those are 1s. 3 divided by 3, those are 1s. So what we have on top is 1 times 1 times 1 times 3, which is 9. And on the bottom, we just have 1. So expanded form can help you understand how to do it if you forget what the rule is, or if you're not sure that you're using it right. You can always write it out in expanded form and simplify it that way. And sometimes that makes a lot more sense to students. Okay, I don't want that to be your main method for solving this, because I want you to use the rules. They're a lot quicker, they're a lot easier. But it's a good thing to have in your back pocket in case you get stuck or you want to check your answer.
Okay.
Okay, good. This video will be really helpful to everybody else too, and that can't come to the Zoom session. So it's a good thing we're going through all these problems.
Is it gonna be on Schoology?
Yeah, as soon as I can upload, I'm recording like every problem we did together, and I'm gonna post it into that week 1 folder as soon as I can upload it. It's been taking a long time where I am. Our internet's not the best. It's been taking a long time to upload videos, but I'll do it as fast as I can. So what do you think? You want to try the rest of them on your own, or do you want to do a couple more?
I think I got it.
Okay, good. Okay, and remember, this is not the last chance you get to talk to me. You have all day tomorrow. I'm going to be at my computer 10 to 3, ready to answer questions. I can make a little video. I can just respond via email, whatever you need. So,
Okay.
so make sure, and even if you want me to just check your answers, I'd be happy to do that too.
Are you gonna post a key like once it's past 3?
Oh, after 3? Yes, that's a great
Okay.
idea. I guess I should write those keys up today, but that's a good idea. After 3, when it needs to be turned in. Now, as far as I know, students can still turn them in late and get late credit, but it's kind of up to the discretion of the teacher. So I guess I need to see how the first week goes, and I'll figure out a plan for dealing with late work. But yeah, I definitely want you to have the answers to these.
Okay.
Okay, so that's a good idea. Thanks for reminding me to do that.
You're welcome.
Okay, Cheyenne, you feeling good? Are you still in here? Okay, cool. All right. Well, if you don't have any other questions, then you're free to go or stay and hang out.
Okay. Thank you.
All right. You're welcome.
Bye. How do
See you
I
later.
do that?